Hi, and welcome to my video on quadratic word problems, rational expressions. What this video is going to be about. Rational expressions are fractions that have polynomials or polynomials in the numerator and or denominator. Let's do some examples. A fraction plus twice its reciprocal is 3 3/10. Find the fraction. Well, first of all, 3 3/10, we change that to 3 times 10 plus 3 is 33/10. Change it to an improper fraction. So we're going to let x be the fraction. And we're going to let 1 over x be the reciprocal of the fraction. And it says a fraction, which is x, plus some, twice the reciprocal, so that's 2 times 1 over x is equal sign, and 3 3/10 is 33/10. So we multiply first x plus 2 times 1 over x is 2 over 1 times 1 over x is 2 over x equals 33/10. In order to solve these equations, I've done a previous unit on rational expressions underneath the section on Algebra 2, and you need to have gone through that in order to realize, in order to solve this equation, one of the ways I do it is by finding the LCD and multiplying the LCD by all terms. And the denominator is 1, x, and 10, so the LCD is 10x. So what I do is I multiply 10x by each term of the equation. And when I multiply 10x times x, I get a 10x squared. When I multiply 10x by 2 over x, the x's cancel, and I get a 20. And 10x times 33/10, the 10's cancel, and I get a 33x. So that, when I have an equation with fractions, multiplying by the LCD every term will cancel out the fractions. And because I have a quadratic, x squared minus 33x plus 22 equals 0. Now, I have to factor this, or I can use the quadratic formula. And what happens if you deal with the factors of 200, 10 times 20 is the product of 200 and the sum of 33, might be a little bit harder to find. So I'm going to do the quadratic formula where a is 1, b is negative 33, and c is 20. So x equals negative b plus or minus b squared minus 4ac all over 2a. And b is negative 33, so it's the negative of a negative 33, plus or minus b squared is a negative 33 squared minus 4 times a. A is, as you can see, a is 10, and c is 20. And all over 2 times a, and a is 10. So that gives me 33 plus or minus. And if you put this in a calculator and work it out, type it in a calculator exactly as you see it, that will come out to be a 289. All over 2 times 10 is 20. And I'll show you that. I have a graphing calculator here. And to do the graphing calculator, and you see it there, clear it, I will go a bracket, negative 33, and the square, and it's negative 33, negative 4. So that's the negative. This is subtract 4 bracket, and the other number is 10. So put it in 10. Bracket, and we put the 20 in. We close it off with a bracket and hit enter. and that gives me the 289. So you can multiply all that out, but if you use your calculator, and note, if you use your calculator and put the brackets around the negative 33 and square it, and you type it in, that's a subtraction there, and that's a negative. So when you work all that out, you get your 289, simplify, then it's 33 plus or minus, and the square root of 289 is a 17 all over 20. So that becomes 33 plus 17 over 20, or 33 minus 17 over 20. That's a 50 over 20, which reduces to 5 over 2. And this one is 16 over 20 and reduces to 4 over 5. So that's the two fractions. If you take this fraction and do its reciprocal and multiply it by 2 and add it up, you'll get 3 3/10, and the same with 4/5. So there's two answers for the fraction: 5 over 2 or 4 over 5. Okay, let's continue. Number 2. Remember now, if you want to pause the video and work out this problem beforehand to see if you get it right, we'll do so. Here we go. The denominator of a fraction is 1 more than the numerator. The sum of the fraction its reciprocal is 13 over 6. Find the fraction. Well, the denominator is 1 more than the numerator, so what we're going to do is let x be the numerator of the fraction. The denominator is 1 more than the numerator, so we're going to, denominator is x plus 1 be the denominator of the fraction. Okay, so the first sentence gives us these two expressions. Then it says the sum of the fraction and its reciprocal. So remember now, that's the numerator and that's the denominator. So the fraction is really the numerator, which is x, over the denominator. So the fraction is x over x plus 1. So the sum of the fraction, which is x over x plus 1, and its reciprocal is x plus 1 over x, is 13 over 6. So I let x be the numerator, x plus 1 be the denominator. That gave me the fraction as x over x plus 1. And its reciprocal is added together with the fraction, gives you 13 over 6. Now, again, we have a fraction and what we call rational expression, which is polynomials in the numerator and denominator. So we need an LCD, and as a reminder just then, the algebra section 2 has the rational expressions in it. Very important to do. Very, very important. So the denominator is 6x and x plus 1, because they're all different. So that's your denominator. So if I take the denominator of 6x and times x plus 1 and multiply it by x over x plus 1 and multiply that denominator also, LCD that is, by x plus 1 over x, and I take the LCD and I multiply by 13 over 6. So again, I have fractions. So by multiplying every term of the equation by the LCD, every denominator should cancel. So x plus 1 cancels. So I get 6x times x. So that gives me 6x squared. The x's cancel, and I get, I'm going to write it down now, because this is, rather than multiply that out, I'm going to write it down and then multiply after. When I multiply here, I get the 6 cancels, so I get 13 times x plus 1. So I'm going to multiply this now. So I multiply this because it was easy. 6x times x is 6x squared. So when I multiply these two, I will multiply the x plus 1 times x plus 1 by 4 as x squared plus x plus x plus 1. First, outside, inside, last. And I multiply this one, I get 13x squared plus 13x. And as in all my math, I like to simplify before I continue. So let me explain. So x plus x is 2x. Now I multiply by the 6. 6x squared plus 12x plus 6 equals 13x squared plus 13x. So now I simplify the left side to make it 12x squared plus 12x plus 6 equals 13x squared plus 13x. And I have both sides simplified, so let's transpose. 12x squared subtract 13x squared plus 12x minus 13x plus 6 equals 0. So all the terms go to the left side because it's quadratic. So the 13x squared becomes negative. The 13x becomes negative and equals 0. So we simplify, we get negative x squared, negative 1x squared, minus x plus 6 equals 0. And I have a quadratic equal to 0, so I'll multiply by negative 1. So negative 1 times all of these terms, I get an x squared plus x minus 6 equals 0. And it's a quadratic, so we'll factor it. X squared is easy to do because I got a 1, we got an x and an x. The factors of the product is negative 6, which is right there. The sum is plus 1. So the factors of 6 are 6 and 1, 3 and 2. So what factors of 6 give you a 1, 3 and 2? And because the product is negative, the sum is positive, then I would have a positive 3, negative 2. Multiply, negative 6, add, plus 1. So x plus 3 equals 0, or x minus 2 equals 0. So x is negative 3, or x is 2. Now, we have x and we have x plus 1. So I have to go x, and x plus 1 is negative 3 plus 1, which is negative 2. And I have x, so x plus 1 is 2 plus 1 gives me 3. So the fraction, remember, is x over x plus 1. So that means I have negative 3 over x plus 1 is negative 2. So the fraction, when x is negative 3, the fraction becomes 3 over 2. And we have a fraction for this one. We have the fraction as x, which is 2, over x plus 1, which is 3. So this fraction is 2/3. So you could have a fraction of 3 over 2 or a fraction of 2 over 3 to give you the sum of 13 over 6. So these are the two fractions that works with this problem. Okay, again, just reviewing the rational expressions on the quadratics. And we have another type of problem here, a little bit different. We have a triangle triangle A, C, E, and BH is parallel to it. So we have AH, which is x plus 1. We have HE, which is x plus 3. And we have BH is x plus 3. We have CE is 6x minus 3. So we want to find, I forgot to find x. I forgot to say what I wanted to find, obviously, not obvious, but we're going to find what x is. So how do we do it? Well, we have to think back in, there's a unit that's done, that I have done on what we call similar triangles. And when we have similar triangles, we have the sides proportional. So what happens is that a little bit more work here. This is parallel to this because of these strokes, arrows given. That means that this angle right here and this angle here are equal, and this angle right here is equal to this one, and angle A is equal to itself, common. So that means the triangle, and I'll outline it like this. The triangles are similar. So this is triangle A, B, H. This is triangle A, C, E. So these triangles are similar because angle A is equal to itself, reflexive. Angle B is equal to angle C, corresponding angles equal when lines are parallel. And angle H is equal to angle E, corresponding angles equal. So these triangles are similar. So the triangle A, B, H is similar to triangle A, C, E. That means if the triangles are similar, the sides are proportional. So we don't have AB and AC in this, so we could have AH. AH goes with AE, and BH goes with CE. So the triangles are similar, AA, and these sides proportional based on definition of similar triangles. Sides of similar triangles are proportional. So AH is x plus 1. AE is the sum of these two. So x plus 1 add on x plus 3 is 2x plus 4. BH is x plus 3. And CE is 6x plus minus 3. So notice again we have rational expressions, two fractions equal with polynomials in the denominator. So what we do here, we go x plus 1 times 6x minus 3 is equal to 2x plus 4 times x plus 3. We cross multiply. Because there's two fractions equal, we can cross multiply. And we simplify these by FOIL. X times 6x, 6x squared. X times negative 3, negative 3x. 1 times 6x is plus 6x. 1 times negative 3 is negative 3. Continue with FOIL. First, 2x squared. Outside, plus 6x. Inside, plus 4x. And last is plus 12. Then we simplify each of these expressions first before we transpose. It makes it easier. So we add up the like terms. So the only like terms is negative 3 and 6 is 3x. 6x and 4x is 10x. Now that we have each side simplified, notice we have a quadratic, so we move all variables and group them together on the left side. So we have them, the 2x squared comes over to give negative, the 10x goes over to give a negative, and the 12 comes over to give a negative. Add up, we get 4x squared minus 7x minus 15 equals 0. So we have a quadratic, and there's two factors that will multiply to give you 0. But if you want, the product is negative 60, because it's 4 times negative 15. The sum is negative 7. Now, to do it this way, you get all the factors of 60 and try to find which one gives you the 7. And that could take a little bit of time, or you could do the quadratic formula. But whatever you do, let's go with the factors of 60. Let's see, 1 times 60. I could use the quadratic formula like I did in the previous one, and it works out. Quadratic formula always works out on a quadratic when it's equal to 0 in ax squared plus bx plus c. 60 got a 1 times 60, 60 got a 2 is even, so it's 2 times 30. Notice that 60 or 30 got a 10, so it's 10 times 6. And notice that I see a 6. A 6 got a 3, so it's a 3 times 20, gives me 60. And I see a 5 times 12. Remember now, I'm looking for the factors. That'll give me a 7. And let's see, 6, no, they add or subtract, no, add 32, subtract 28, add 16, subtract 4, no. 3 and 20, add 23 and 17, no. 12 and 5 and 12, add 17, subtracts, oh, so the factors are 5 and 12. But the product is negative, so one got to be plus and one got to be a minus. So the plus 5 minus 12, because the sum is negative, the larger factor got to be negative. So 4x squared plus 5x minus 12x minus 15 equals 0. And notice when you add these two up, you get the negative 7. So that means x comes out of the first two, because we're going to do grouping of these two. That gives me 4x plus 5. And I take a negative out, and I see a 3, that's common. So I take a negative 12 divided by negative 3 is a 4x. Negative 15 divided by negative 3 is a plus 5. So 4x plus 5 is common. What's left is an x minus 3. Again, the quadratic formula will give you the answers right away when you work it out correctly. So I have 4x plus 5 equals 0, or x minus 3 equals 0. 4x equals negative 5, divided by 4, x equals negative 5 over 4. And here x equals 3. So I have to check. X is negative 5 over 4. So if I put a negative 5 over 4 right here, and add 1, that means I get a negative 5 over 4, add on 4 over 4. So if I put a negative 5 over 4 into this length of h, the length becomes negative. So I can't use this negative number. Not that it's negative. It's when it makes the length negative, I can't use it. Because there are problems when you have negative numbers, and they work because they'll give you a plus length in the side of a triangle. So I can't use negative 5 over 4, but I can use 3 because 3 is positive. So the value of x is 3. So the answer is 3 is the answer. That's the value that makes these triangles size proportional. Makes it true. Again, just a different one, but it's based on knowing the similar triangle. Or you didn't have to do a full formal proof. You just recognize that the triangles have equal angles and the triangles are similar. Notice I drew the two triangles as I did in my unit on similarity. Drawing the triangles and putting in the length of the sides like that, and putting in 2x plus 3, and putting in x plus 3 and 6x plus 3, or 6x minus 3. You could write out the proportion based like this, or you can fit in the triangle and then say x plus 1 over 2x plus 3 equals x plus 3 over 6x minus 3 to get proportion without writing this down. But that's working out the working out the quadratic word problems with rational expressions, and I work it out by multiplying by the LCD. And if you like my video, click the like button, subscribe button, the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's in my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.